Curious Cosmos welcomes you all. Did comets bring water to Earth? NASA's latest discovery could change everything. For decades, scientists have debated one of Earth's biggest mysteries: how did our planet become so rich in water? It's a question that touches on the very origins of life itself. While some theories point to asteroids as the main water carriers, recent research has reopened the possibility that comets, icy travelers from the outer reaches of the solar system, may have played a crucial role. And the latest findings from a NASA-led team are shaking things up yet again. Why does Earth's water even need an explanation? Water is the lifeblood of Earth. It covers 70% of our planet's surface, sustains ecosystems, and is essential for life as we know it. But here's the kicker: when Earth formed about 4.6 billion years ago, it was far too close to the sun for liquid water to stick around. The sun's intense heat would have vaporized most of the early water, leaving our planet dry and barren. So where did all this water come from? One prevailing theory is that volcanic eruptions released water vapor, which eventually condensed and rained down to form oceans. Another leading idea is that celestial bodies, like asteroids and comets, delivered water to Earth during a chaotic period of impacts roughly 4 billion years ago. Scientists have long agreed that asteroids contributed a significant portion, but the role of comets has been much more controversial. Comets, the icy time capsules of the solar system. Comets are fascinating objects. Often called dirty snowballs, they are made up of ice, rock, and dust and are thought to contain some of the most primitive materials from the early solar system. Jupiter family comets, in particular, are believed to have formed far beyond Saturn's orbit in the cold outer regions of the solar system. This icy origin makes them prime suspects for delivering water to Earth. To test this theory, scientists look at the unique molecular fingerprint of water. Specifically, they measure the ratio of deuterium, a heavier isotope of hydrogen, to regular hydrogen in the water molecules. This ratio serves as a cosmic clue, revealing where the water likely formed. Objects farther from the Sun tend to have higher deuterium levels due to the colder conditions. The case of Comet 67P, a game changer? In 2014, the European Space Agency's Rosetta mission made headlines when it studied Comet 67P/Churyumov-Gerasimenko up close. At first, scientists were hopeful that its water might match Earth's. But instead, the measurements revealed a shockingly high concentration of deuterium, 3 times more than what's found in Earth's oceans. This seemed to disqualify comets like 67P as major contributors to Earth's water supply. It was a big surprise, says Kathleen Mant, a planetary scientist at NASA's Goddard Space Flight Center. We had to rethink everything. New research, dust changes the story. Fast forward to today, and Mant's team has revisited the data with fresh eyes. Using advanced computational techniques, they analyzed over 16,000 measurements collected by Rosetta during its mission. Their focus? Understanding how dust, the tiny particles surrounding the comet, might have skewed the original results. Here's what they discovered. When a comet approaches the Sun, its surface warms up, releasing gas and dust. This dust often carries small amounts of water ice, which can influence the deuterium measurements. Because deuterium-rich water sticks to dust grains more easily than regular water, the readings near the spacecraft may not reflect the true composition of the comet's core. Essentially, the dust was making Comet 67P look more deuterium-heavy than it really is. When the team factored in these dust effects, they found that measurements taken farther from the comet, where the dust had dispersed, were much closer to Earth's water in composition. What does this mean for Earth's water? This discovery has big implications. It suggests that previous studies might have underestimated the role of comets in delivering water to Earth. If comets like 67P indeed have water with a deuterium ratio similar to Earth's, it reopens the case that they were significant contributors during the planet's early history. This means there's a great opportunity to revisit past observations and prepare for future ones, Mant says. By refining how we account for dust effects, scientists can gain a clearer picture of comet compositions and their role in the solar system's history. Why should we care? Understanding the origins of Earth's water isn't just a scientific curiosity, it's key to understanding the conditions that make planets habitable. If comets played a larger role than previously thought, it could reshape how we search for life on other worlds. For instance, icy moons like Europa and Enceladus, which have vast subsurface oceans, might hold clues to their own watery origins. Moreover, studying comets helps scientists piece together the puzzle of our solar system's formation. These icy bodies are like time capsules, preserving information about the early days of the Sun and planets. Each new finding brings us closer to answering profound questions about our place in the universe. Rocket, thank you for exploring this cosmic mystery with us. If you love diving into the universe's biggest questions, don't stop here. Subscribe to Curious Cosmos, Milky Way, hit that like button, share this video with fellow space enthusiasts, and leave a comment below with your thoughts or questions. Don't forget to click the notification bell so you never miss our next exploration into the wonders of the cosmos. Your curiosity fuels our journey.